Here's problem number 15 from section 8.3. We want to know whether this function goes faster or slower or at the same rate as e to the x. So let's go ahead and let's take the limit as x approaches infinity of the square root of 1 plus x to the fourth over e to the x. Now, when we apply the limit, both of these things are going off to infinity. It's indeterminate in the form infinity over infinity. So there's no problem applying L'Hopital's rule in this case. So I drop the exponent. That's supposed to be a 1. Leave the inside the same. Lower the exponent by 1. And I see what I'm going to get is a really big mess here. And this is all over the derivative of e to the x, which is just e to the x. And the more I look at this, the more I'm thinking there's a better way to do this problem, and that is I'm going to take a quick look at x growing, the rate at which this is growing, and I actually know that this is moving is a bit about the same at the same rate as x squared. If I multiply both top and bottom by 1 over x squared, then I end up getting the limit as x approaches infinity, and under the square root I get 1 over x to the fourth plus x to the fourth over x to the fourth all over 1, which is the limit as x approaches infinity of 1 over x to the fourth plus 1 over 1. Now when I apply the limit, that goes to 0. We get the square root of 1 over 1, which is just 1. Now why would I do that? Well, I do that because it shows that these two are moving at the same rate. So now it's easier for me to show that x squared over e to the x, I can, because of the transitive power of these rate changes, I can do this one. It's indeterminate in x over as in the form infinity over infinity. So let me apply L'Hopital. This is still indeterminate in the form of infinity over infinity. So let me apply L'Hopital again, and this goes to 0. If this goes to 0, that means e to the x, let's do it this way, x grows slower than e to the x, and since x and square root of 1 plus x to the fourth, x squared grows slower than e to the x, and since x squared grow at the same rate, that means the square root of 1 over x to the fourth is slower than e to the x. And that's number 15.